Now let's look at what you send, because that's for sending frames that we do all that. Of course, there are some frames that contain data. That's your FTP or your voice sound. That's kind of obvious. But around, you saw already the acknowledgement, so there are some other frames. And in fact, there are some different types. There is one type of frame that could be data that is actually empty. So you send a frame, it's a data frame, and it doesn't have any data. Why would you do that? Well, you can do that in some cases where you want to tell something to the access point about your status. For example, the fact that you're awake, you're not sleeping, you're back on the network after having been in power saving mode. Then you're going to send that frame. It doesn't have any special data to transmit, but you want to tell the AP that if it has something for you, you're here. So you're going to send that data frame. It just will not have any data payload. It will just have an empty body. But in the header, there will be your MAC address, and there will be a field that says that you're awake, for example. So that's data frame. Most of them will contain data, a few cases where there will be empty frames. And there are also some management frames. What we call management frames are frames that help you understand the network around you, discover it, join it, etc. In this category, there are the beacons, the probe request, and the probe response. We'll come back in a sec on those two. Then there is another type of management frames, which is not only for discovery, but it's also to be able to join the network. And that's what we call the authentication frames. And there is, of course, authentication request and response. And then there is a final phase when you want to join a cell, which is called the association phase. And here again, we have two frames, and they also belong to the management category. There are actually a few more in the same type of family: deauthentication, disassociation, reassociation. It's the same type of structure, same type of purpose. So data, then management. And then there are a special type of management frames which are called actions. They are in the management category, but they are very specific, because what they do is that it's when your station or when your access point needs to say something special that forces the other side to do something. For example, you remember DFS with the radars on some frequencies? Well, the access point can ask the client, hey, can you go scan this channel and tell me if you hear radar? Or the access point can tell, I'm moving away to that channel, join me on that channel. So you see, it's when you want to push the other side to do something. So it's still a form of management, but they are very specific, and actually the action frame is a very broad family where there are almost, if I recall, 15 different subtypes of action frames. So it's a very vast subject. And beyond these data and management frames, a third category is what we call control frames. Not many of those, but you know already some of them. The acknowledgement. There are two others, the RTS, request to send, and clear to send. All three are what we call control, and their job is to make sure that communication works smoothly. Let's look a little bit more in detail to those frames. The first one is that they all have the same structure. There is always an 802.11 header, and that header is always built the same way. What is going to change from one frame and to the other, from one frame type to the other, is the body or some additional parts that are added to the header. But the initial section of the header is always the same. And that header has a first section which is called the frame control, followed by some field that we call the duration field. It's called the duration ID because in some cases it can also be an identifier, but that's a subcase that is not very frequent. So let's call it the duration field. And then there are addresses, and you see 3 of them, and sometimes actually 4. Then there is something we call the sequence control, that for MAC address if you use it, and then some other fields in some cases like the QoS field if you use it. Okay, and then there is your frame body, and of course the frame check sequence. So what do we have here? In the frame control, it's the information about what the frame is about, what that frame is supposed to be representing. You see, it's 2 bytes long. It has a protocol version which is 802.11, so that's not very important. What is important is type and subtype. This is how you're going to know if it's management, if it's control, if it's data, and if it's management, what kind of subtype this is going to be. So that's very important. Then there is this to DS and from DS section. So DS, distribution system, remember that's the connection of the access point to the rest of the infrastructure outside of the cell. So when the frame is 2DS, it means that it's typically sent from a station to the access point, and then the station says, send that over, whatever that is, I don't know. That's your job as an access point. When it's from DS, it's probably coming from the access point through the access point and going down to a client. And then what is interesting here, and what is complex too, is that depending on what combination of to DS and from DS you have, the MAC addresses you see at the back are not going to mean the same thing. And the reason why is, if you think about it, imagine that you have two laptops communicating with each other through the access point. One laptop is going to send a frame to the AP, and the AP is going to repeat that frame to the other client. But at some point, that source client needs to tell the access point, I'm sending this frame to you, Mr. Access Point, but it's not for you. It's for the other guy. It's for the other station. So you see, we have a need of two destination MAC addresses here. One is going to be what we call the receiver address, that is to say the destination for that frame now, which is the access point, but it's not the final destination. The final destination is going to be the destination address, DA. And the same way, when the access point sends the frame to the client, it's going to say, all right, I'm sending a frame to you, it's from me, but you know, I'm the sender, it's not from me, I'm not the source. So here again, on the source side, you can say the source address, which is the SA, and you can also say who is transmitting the frame, the transmitter address, TA. RA, DA, TA, SA, you have these different concepts. And of course, depending on where the frame is, you may have two of those, but only one of the other kind, and vice versa. So when you go from the first station to the access point, there is only one source. So SA and TA are the same, so you don't need to repeat it twice. But you need to tell who is the RA, receiver address, probably the access point, that the others don't take that frame, and who is the DA, what's the final destination. And on the other side, you don't need to say what is the DA and the RA because it's the same station, the final destination, but you need to say who is the TA and who is the SA. Whenever in those combinations the MAC address is the access point, you mention the BSSID, which is the MAC address of the access point. So depending on what the to DS and from DS fields say, the address 1, 2, and 3 will not mean the same thing. Are you supposed to know these combinations? Well, you're likely to understand them, right? If you keep in mind this example with this two-station thinking, you will immediately have in mind a clear picture of which ones you need and which ones are not necessary. Then you just need to look at this table at the bottom to know that it's just one after the other in the sequence of who we send and from whom we send it. Okay, so that's the to DS, from DS, and the MAC addresses. Important for you to understand what they do. There are more fields in the frame control section. There is a retry, power management, more data, etc. Those are used in some very specific cases. Did you notice that there is only one case where address 4 is being used? And that's where from DS and to DS are both set to 1. So when does that happen? Well, that may happen, for example, in a mesh network, where you have an access point forwarding a frame to another access point, coming from a client and going to a client. So in that case, they need to say who is the original source and who is the original destination, on top of who is the sender and who is the receiver. That's the only case, so it's a very uncommon case, especially indoor.